So this is part A of 59. Did I dork something?
Wait.
Okay. All right, so I just want to simplify this, and part B is solve something similar. So how do I simplify this? Yeah, okay, so we look at this and we think, all right, what's the common bottom here? Let's see, yeah, there's a x plus 1, and then there's a x minus 2. Great, good eye, guys. All right, so what do I do with that? Okay, we're going to force that, right? So we're going to say, okay, what does the first term need? It's got an x plus 1, right? It needs a x minus 2 top and bottom. Okay, how about the 1? What does that thing need?
That needs both.
Both?
Yeah.
And because it's a 1, it's going to be pretty easy, right? I just get x plus 1 times x minus 2 over x plus 1 times x minus 2. Right? There's really a 1 here that I'm multiplying by, but I don't need that so much. Okay, then what? Okay, so the last term's x minus 6 over x minus 2, and it needs a x plus 1 top and bottom. Okay, cool. So now all this is over the common bottom. Okay, so there's a x minus 1 times x minus 2 minus x plus 1 times x minus 2 minus x minus 6 times x plus 1. And then all of this is over the common bottom, right? Okay, now what? So 1, remember, I only really distribute as a last resort, right? So why am I thinking distribute's a good idea here?
Because of the minus.
Yeah, there's a bunch of plus and minus kind of off things here, right? Like this guy's x plus 1 times x minus, or sorry, this guy's x minus 1 times x minus 2. And here's an x plus 1 times x minus 2. Right? I see that some stuff is going to cancel, so I think, oh, this might be a good idea. Cool. The other thing I'm eyeballing here is what am I going to end up with on the top?
A lot of
What's the
squares.
Yeah, there's going to be a lot of x squares. Are there going to be any x cubes?
No.
No, I know how to solve quadratics, so maybe this is a good idea. You guys see that? All right, so if we start foiling some stuff out, let's see, don't bother foiling the bottom. Why not?
Because then you're going to cancel.
Yeah, because nothing's going to cancel down there, right?
That's a false count.
Yeah, and I could maybe try to false cancel here, but I shouldn't do that because I just put that bottom in there. I had to have it, right?
Yes.
Okay, so I got to here. Now what do I do with the top? Okay, foil it out. So I get a,
X squared
okay,
minus 3x.
minus 2x. Outsides,
Minus 1x.
insides is minus x, plus 2 for the lasts. And I had better keep my signs straight here. Okay, then I'm going to subtract.
X squared.
Are you guys prone to screw up the thing I'm doing right now? I certainly am. What are you going to forget? Yeah, that minus sign needs to go on the whole thing. So I would personally do this. All right, I'm going to subtract, right? And then foil in here. Yeah, and then I'll distribute this sign at the next step so I don't lose it. All right, so what do I get when I FOIL in here? I got an x squared. There's a minus 2x from the last. From the insides, there's a 1x. I said last, I meant outside. And a minus 2 from the last. And then minus again and another set of parentheses. Okay. Plus x minus 6x minus 6. Okay. So then I might say, all right, let me combine some like terms right now. Which like terms am I going to combine right now? No, I have to distribute for those, right? But before I distribute, there's some I can get. Yeah, there's a 2x minus x here. That's a minus 3x. Right here, there's a, that's a minus x. And right here, there's a negative 5x.
I like how you're doing that because I read it all out.
Yeah, and then you probably missed one of the signs, right?
Yes.
The reason I'm doing this is that I'm bad at flipping signs. If I can get 3 signs to flip instead of 4, I feel like that makes me more likely to get it right. Does that make sense? All right, so I got, and this is still all over x plus 1 times x minus 2. Okay, now what's this step that I'm doing? Yeah, this should be distributing signs, right? Okay, so I got, in the first bit, do I need to distribute anything there? No. So I got x squared minus 3x plus 2. Okay, then when I distribute the sign through the second thing, what do I get? Very nice, guys. Right, the minus goes on this piece, and on that piece. And then out of the last guy, what do I get? I get a minus x squared plus 5x plus 6. Okay, now what do I do?
Combine like terms.
Yeah, now I go through and combine like terms. So I don't know if you guys do this, but I like to say, okay, we go through and just, those are the x squareds, right? I'm just going to go ahead, group all the x squareds. So now what do I see about the x squareds?
That they're going to cancel out, so you're left with 1 negative x squared.
Yeah, this guy and maybe one of those guys is going to cancel. So in the end here, I'm going to be left with a minus x squared. Okay, then what?
And the x's.
Okay, so let's get all the x's. So there's some x's, there's some x's, and there's some x's. This is really just to make sure I get everything, right? So how many x's have I got? Let's see, yes. So that's 6 positive x's and 3 negative ones makes plus 3x. Okay. Then I go through and I get, all right, there's numbers, numbers, numbers. Those were plus signs before I drew purple all over them. So that was 2 and 2 and 6 is 10. Cool?
And then in the book they make it so.
Wouldn't the 5x be negative? It was a x minus 6x is a minus 5x, right? And then I distributed this negative sign through.
I get it.
Okay. Cool. Am I done?
No.
Not quite. What do I need to do now?
Now you need to do the 2 and 5.
Yeah, I'm kind of hoping that I can cancel something, right? Okay, so I might factor the top. To make my life easier on factoring the top, you guys see that? Is there a way I can make my life easier? Yeah, what is it? Yeah, pull a negative sign out. So I could say, okay, this is the same thing as if I pull a negative 1 out of there. What do you get when you pull a negative 1 out of there?
Change the sign.
Okay, so we get a times x squared minus 3x minus 10. Very nice. Okay, and then I think to this, or think at this maybe. Let's see, I need add to negative 3 and multiply 5 times 2. Yeah, so 5 and 2 do this, and 5 minus 2 is 3, so maybe I can make this work. I just need to check the signs, right? Okay, so say, all right, this is negative 1, and then I'm hoping to break this into 2 pieces, right? And it's still over this. Okay, so maybe there are a 5 and a 2, and I just need to get signs right. Positive 2, negative 5. Okay, so 2 minus 5 is negative 3, and 2 times negative 5 is negative 10. Great. All right, so here I am. Can I cancel anything? Careful. Why or why not? Yeah. So if I distribute the negative 1 in here, right, I'll get the minus 2 that matches down here, but I'll get a negative x. Can't cancel those. So remember, you can pull a negative 1 out and cancel when both the signs are different. But here I've just got the middle sign different. That's not enough. Cool? All right. So this is simplify, right? This was part A. I get to here. Okay, and then I go read part B, right? Part B says solve a very similar thing. Okay, so 59 part B says solve, and then it's x minus 1 over x plus 1 minus 1 equals x minus 6 over x minus 2, right? I think this is 59b. They replaced this minus sign with an equal sign and ask you to solve instead of simplify. Yeah. Okay, so are you going to go through this whole rigmarole again?
We're going to get rid of the bottoms to get all together.
Okay, you can blast the bottoms right away, but you already did a bunch of work, right? You already simplified that thing that looked very similar.
Yeah.
So let me just use that.
Oh.
How can I get this thing, right, in this problem? Well, I've already got the x minus 1 over x plus 1 minus 1 part, right? And then I need a minus this thing. You guys see that? That says to me that maybe I could be a little clever and just subtract that thing to the other side. You see that? So then I'm going to get,
So it's literally the exact same thing.
yeah, so I'm going to take this thing that's on this side of the equality. I'm going to move it to the other side. It's going to get a minus sign in the process, right? Yeah, and I'll get equals 0, and I'll have this side is going to be the exact same thing I was just playing with. See that? Now this is saying set the answer from 59a equal to 0. Okay, see that? Okay, I know what the answer from 59a was. It's this thing. Cool? So I can buy myself a little bit of ease here, right? I already did some work. I may as well use it. So I can just take this thing, my minus 1 times x plus 2 x minus 5 over x plus 1 times x minus 2. Set this equal to 0. Now I can blast the bottoms, right? You guys see that? What do I multiply by to get rid of the bottoms here? Yeah, I can actually just multiply by the whole bottom, right? I'll get negative 1 times x plus 2 times x minus 5 is 0, right? Why didn't I get anything over here? Yeah, because I took stuff and multiplied it by 0. That's still 0. Where'd the bottom go over here? Yeah, it canceled with the thing I multiplied by. Really, this is saying, right, and there's a thing you could think here. That's a good thing to know. Don't really have space. Really, we could think here, okay, I've got a fraction, right? I'm wondering when that fraction's equal to 0. Oh, fractions are 0 when the tops are 0. You guys see that? Okay, so that's really what I did. I just took this fraction, I said, oh, well, let me set the top equal to 0.
So the bottom is 0 is undefined.
Yeah, bottom is 0 makes undefinedness, right? Top is 0 makes 0. Cool. So I wouldn't want to set the bottom equal to 0 unless I was looking for spots where it was undefined, right? Which really I should check at the end. But right now I'm just looking for when is the top 0. So I got this. What do I apply to this? Yeah, apply the 0 product rule. Or what else could you do? I would really recommend towards the 0 product rule here. Yeah, you could multiply it out and then apply the quadratic formula to it. You're going to get the same thing as the 0 product rule, but you're much more likely to make a mistake, right? But if the 0 product rule departs from your brain for a moment, quadratic formula will work. Okay, so I use the 0 product rule, and what do I find? I find that x plus 2 is 0, or x minus 5 is 0. You guys see that? Is there one more or I should write here? Yeah, or minus 1 is 0. Does that one happen? Not really. Okay, so I can drop that one. It's never true, right? When's this one true? Yeah, when x is minus 2. Or when's this one true? X is 5. Okay, so these are tentative solutions, right? Then what do I need to check? Yeah, I need to make sure that they don't cause division by 0, right? So I take those two and I stick them back in here. Really just in the bottoms of here, right? So if I plug in negative 2, the bottom of this guy is negative 1. Right, negative 2 plus 1. And in this guy, it's negative 4. Either way, not 0, right? And when I plug 5 in, I get 6 in the bottom for this guy and 3 in the bottom for that guy. No division by 0. I'm good with these two. If you don't think to do this subtract thing, right? If you don't think to use 59a, which admittedly is fairly clever, what are you going to end up doing? You're going to end up working the exact same problem all the way through again. Cool. It's not bad. It's good practice, but you really should, you should get the wait, all of this stuff I'm doing feels really familiar, right? Like, oh, I foiled these things out just a second ago when I did A. What the heck? But it's the subtraction that's making that happen.
Okay, when you're plugging what we just did back into it,
Yeah, I'm saying, okay, in part A, we simplified this left-hand side thing, right?
Right.
When I look at this, I see, oh, if I move this over there, then that thing I simplified before will be the left-hand side here. Then I could just copy my work down, right? Or even just the answer, and stick it in there, because I know this is equal to the answer I got for 59A.
Okay, we're keeping it the same because we're just putting the negative in front of the parentheses. I was wondering why it wasn't changing the signs, but that's why.
Oh, yeah, there's a negative here. It turns out it doesn't matter, right?
Okay.
Really, here we could divide by -1 and then apply the zero product rule. We'd get the same thing. That's really saying -1 isn't 0.
Okay.
Cool?